Welcome back to AI Explains Everything, the video series where we use artificial intelligence to explain complex concepts. In this episode, we'll be taking a deep dive into computer vision, one of the most exciting and rapidly developing areas of artificial intelligence. We'll be exploring the history of computer vision, the key techniques and technologies used in this field, and some of the most exciting current and future applications of computer vision. Part 1. History of computer vision. Computer vision has come a long way since the early days of artificial intelligence, when researchers first began exploring the idea of teaching machines to recognize and interpret visual information. From its humble beginnings with simple algorithms capable of recognizing basic shapes and patterns, computer vision has evolved to become a crucial component of modern technology, with applications ranging from autonomous vehicles and facial recognition to medical imaging and robotics. The earliest examples of computer vision can be traced back to the 1950s, when researchers began exploring the idea of using machines to recognize and classify visual information. One of the most notable early contributions to the field was the perceptron algorithm, developed by Frank Rosenblatt in 1957. The perceptron was a machine learning algorithm that could be trained to recognize simple shapes and patterns, such as lines and circles. While it was limited in its capabilities, the perceptron laid the groundwork for future advances in computer vision. In the following decades, researchers continued to develop more sophisticated computer vision techniques, using approaches such as template matching, edge detection, and feature extraction. Template matching, for example, involves comparing an image to a predefined template to determine if there is a match. Edge detection algorithms, on the other hand, identify edges and boundaries in an image, which can be useful for tasks such as object detection and segmentation. One of the key breakthroughs in computer vision came in the 1990s, with the development of scale-invariant feature transform (SIFT) algorithms, which allowed machines to recognize objects and patterns even when they were scaled or rotated. SIFT algorithms work by identifying key features in an image, such as corners and edges, and then comparing these features to a database of predefined features. By matching these features, machines can recognize objects even when they are viewed from different angles or distances. Another major development in computer vision came in the early 2000s, with the introduction of deep learning techniques, which use artificial neural networks to process and classify visual information. Deep learning has enabled machines to recognize and classify objects with a high degree of accuracy, even in complex and cluttered environments. One of the most notable examples of this is the ImageNet dataset, which contains millions of labeled images and has been used to train deep learning models for object recognition. Today, computer vision is a rapidly growing field, with new applications and techniques being developed all the time. One of the most promising areas of research is in the development of real-time computer vision systems, which can process and analyze visual information in real time, enabling applications such as autonomous vehicles and augmented reality. Autonomous vehicles, for example, rely heavily on computer vision to navigate and make decisions in real time. They use a combination of cameras, lidar, and radar sensors to detect objects and hazards on the road, and then use computer vision algorithms to analyze this data and make decisions about how to safely navigate through the environment. Similarly, augmented reality applications use computer vision to overlay digital information onto the real world, allowing users to interact with and manipulate virtual objects in real time. Medical imaging is another area where computer vision is making a big impact. Computer vision algorithms can analyze medical images, such as X-rays and MRIs, to detect and diagnose diseases and abnormalities. They can also be used to monitor the progress of treatments and to assist in surgical planning. Part 2. Key techniques and technologies. Today, computer vision is a highly sophisticated and multifaceted field, incorporating a wide range of techniques and technologies. Some of the key techniques used in computer vision include image preprocessing. This involves cleaning and transforming raw image data into a format that can be easily processed by machine learning algorithms. Feature extraction. This involves identifying key features of an image, such as edges, corners, or textures, and using those features to build a model of the image. Object recognition. This involves identifying and labeling objects within an image, such as cars, people, or buildings. Image segmentation. This involves dividing an image into smaller segments, each of which can be analyzed separately. Deep learning. This involves using artificial neural networks to learn from large sets of labeled image data, and using those models to make predictions on new and labeled images. Some of the key technologies used in computer vision include cameras. These are the primary input devices for computer vision systems, providing visual information that can be analyzed and processed. Graphics processing units, GPUs. These specialized processors are designed to handle the complex mathematical calculations involved in computer vision algorithms. Sensor fusion. This involves combining data from multiple sensors, such as cameras and lidar systems, to create a more complete picture of the environment. Augmented reality. This involves overlaying digital information onto the real world, using computer vision techniques to recognize and interpret real-world objects. Part 3. Applications of computer vision. Computer vision has a wide range of applications, from autonomous vehicles and robotics to healthcare and entertainment. Here are some of the most exciting and promising areas of application for computer vision. Autonomous vehicles. Computer vision is a key technology for enabling self-driving cars and trucks, allowing vehicles to see and interpret their environment in real time. Robotics. Computer vision is also used extensively in robotics, allowing robots to perceive and interact with their environment in a variety of ways. Healthcare. Computer vision is being used to analyze medical images, such as X-rays and CT scans, to aid in diagnosis and treatment of disease. Security. Computer vision is used in surveillance systems, facial recognition software, and other security applications. Entertainment. Computer vision is used in video games and virtual reality applications to create immersive and realistic environments. Part 4. Challenges and limitations of computer vision. Despite the many advances made in computer vision, there are still some significant challenges and limitations to this field. One of the biggest challenges is the problem of adversarial examples, which are images that have been carefully crafted to deceive computer vision systems. For example, researchers have shown that it's possible to create an image of a panda that is indistinguishable from a random collection of pixels to a human, but that is classified by a computer vision system as a gibbon. Another challenge is the problem of bias in computer vision systems, which can lead to unfair or inaccurate results. For example, if a computer vision system is trained primarily on images of white people, it may not be able to accurately recognize people of other races. 5. Future of computer vision. Despite these challenges, the future of computer vision looks incredibly promising. Some of the key areas of focus for future research and development include improving accuracy. Researchers are working to develop more accurate computer vision systems, particularly in areas such as object recognition and facial recognition. Addressing bias. There is growing recognition of the importance of addressing bias in computer vision systems, and researchers are working to develop more fair and inclusive systems. Expanding applications. As computer vision technology becomes more advanced, we can expect to see it used in an ever wider range of applications, from agriculture and manufacturing to environmental monitoring and space exploration. Developing new techniques. Researchers are constantly developing new techniques and approaches to computer vision, such as generative adversarial networks, GANs, which can be used to create realistic images and videos from scratch. In this episode, we've explored the exciting world of computer vision, from its early roots in artificial intelligence to its current state-of-the-art techniques and technologies. We've looked at some of the key applications of computer vision, as well as some of the challenges and limitations that researchers are working to overcome. And we've discussed some of the exciting possibilities for the future of computer vision. Thanks for joining us, and we'll see you next time on AI Explains Everything.